Hello, this is Frank Allen of Davis High School. This is a lesson on isotopes in Unit 3 of our curriculum. If you're a student who is retaking something or retaking a test, this is a lesson on isotopes. You will have several questions over isotopes on the test. So exactly what is an isotope? Well, the name's a little bit foreign to you. It's not something that the name doesn't really reveal too much about it, but it's atoms of an element with different number of neutrons. Let's take carbon for instance. Now carbon atoms all have 6 protons and 6 electrons unless they lose or gain some electrons. Some carbon atoms have 6 neutrons, and these are the neutral particles located inside the nucleus. Some carbon atoms have 8 neutrons. They're the same, they have pretty much the same properties, but they're a little bit different because this one has 2 more neutrons than this one. And so these are 2 isotopes of carbon, atoms of an element, the same element, with different numbers of neutrons. Now, how are we going to write this down and symbolize this so that if we're talking about this carbon atom, we know the difference between this carbon atom? Well, we sort of have to give them a name. You can think of them as twins, maybe. One twin would be carbon something, and the other twin would be carbon something else. What we're going to do is combine these 2 numbers. They give us the mass of the atom. The electron doesn't really have any mass. So these 2 numbers we're going to together combined we're going to call the mass number. Now you don't really have to know the vocabulary word mass number, but you do have to know what this means. If you see this number following it, it means that this is the number of both protons and neutrons added together. So this particular isotope would be carbon 14. So carbon, these 2 isotopes, this particular atom has 12 things in its nucleus. This one has 14 things in its nucleus. They both have 6 protons. This one has 6 neutrons, and this one has 8 neutrons. So you might see something like this on the test, where you have a box, a chart, and you have the number of protons and the number of neutrons. And we may, for instance, sometimes we use the symbol instead of the name. So you may see something like K40. And using the periodic table, you always get to use the periodic table. You would look at the periodic table, and the periodic table begins with a P, and it gives you the number of protons, and the number of protons for potassium is 19. And so the number of neutrons would therefore be 21, because 40 minus 19 is 21. Another example, you might see something that looks sort of like this, where you have to give us the name. Well, we know that 4 and 5 is 9. This is the number of protons and neutrons, so that corresponds to this number here. But what element is this? Do the neutrons tell us the element, or do the protons tell us the element? Well, the protons tell us the element. And looking on the periodic table, we see that it's beryllium, and you can either write out the name or you can just use the symbol Be-9. So once again, these are isotopes. They're atoms of an element, the same element. They have different numbers of neutrons. That gives it a slightly different mass. And one final example, maybe you have sodium 23. Can't write that 23 in there, so I'll write it below it. So you would need to know the symbol for sodium. It's Na. You look on the periodic table, that gives us 11 protons. 23 minus 11 is 12. Don't try to remember that you need to subtract this or add that. You simply need to know what this number here means. It's the number of protons and neutrons. And you need to know that you get the protons from the periodic table. And then you can figure out that you would subtract this from that to get the neutrons. So once again, isotopes, atoms of an element with different numbers of neutrons, be able to take the name and give us this, or be able to take this and give us the name. This will come into play later on when we're talking about radiation, nuclear chemistry. Some isotopes are radioactive, and the reason they're radioactive is because the number of neutrons, or the ratio of neutrons to protons, isn't quite what gives the atom enough stability. So it will undergo some type of change to become stable, and that's basically what radiation is. But rewatch this 1 or 2 times, make sure you understand isotopes, and we'll see you in the next video.